Hello everyone, welcome to Tuteetute. In this video we will see the previous question paper of TS GENCO, that is 2015 TS GENCO question paper related to electronics stream. First question, a PCM system uses Nyquist sampler, a uniform quantizer followed by a 5-bit binary encoder. So question is related to PCM and 5-bit binary encoder, that means n is equal to 5. Okay. The bit rate is 50 megabits per second. Bit rate is 50 megabits per second. The maximum message bandwidth for which the system operates satisfactorily is. So we need to calculate maximum bandwidth. Okay, maximum bandwidth we have to calculate. Generally, when we send only one bit having the duration TB, okay, its spectrum is given like this. Na? So here you will be having 1 by TB. So the bandwidth is 1 by TB we are getting. When you send 2 bits, for example, if you take both are ones only, it is 2 TB, then the bandwidth will become 1 by 2 TB. So it is some lesser than this one. So maximum bandwidth you will get when you send only one bit at a time. Okay. And it is given according to the bit duration only. Okay. So bit rate is nothing but what? This one, 50 megabits per second. So answer will also be 50 megabits per second. Okay. Next. Two signals S of t and R of t are to be transmitted over a common channel by means of time division multiplexing. So two signals are there, R of t and a S of t. So according to time division multiplexing, we need to send these two first through low pass filters. Next here one commutator will be there. So this is connected to this one, this is also connected to this one. To complete one rotation, this commutator will take TS seconds, that can be considered as a frame time or sampling interval. Okay. So to complete one rotation, it will take that much amount of time. After this is actually performing the sampling process. So after sampling, we are having quantizer and then encoder. Next channel will be there. Whatever we are getting this side, that will be decoded and then given to decommutator. So here decommutator will be there. It is in synchronization with the commutator. Then again here we will be having two low pass filters. Like this, here again we will get the same signals S of t and R of t. So the arrows if I give, you can understand the flow. Like this. Okay. So this is the time division multiplexing diagram. So the highest frequency of S of t is 1 kHz. So it is having the frequency 1 kHz. That of R of t is 1.5 kHz. Its frequency is 1.5 kHz. Okay. The minimum value of the permissible sampling rate is. Okay. That is what they are asking. Actual thing is, the sampling interval TS is given like this. How many number of bits we have taken? N. How many signals we are working with? Capital N. Okay. And in the given data, there are no extra bits. So this is enough. If you have any extra bits, plus A you have to take. Okay. And each bit duration is how much? TB. That means within one particular rotation, this commutator is taking TS seconds for one rotation. So per one rotation, it is related to how many bits. That is what we are taking. Okay, how many bits? Two signals are there. It will be available at each signal one time only. Okay, here one time, here one time, within one TS rotation. So it will be available one time at S of t and one time at R of t. Okay, and whatever the sample is getting from this particular S of t, that will be converted into n bits using encoder. Here also n bits, that means 2n bits. Why 2? Because 2 signals. If it is 3 signals, 3n. That's why n, like that we have taken. And each bit is available for TB seconds. So this is TS is equal to nn plus nn into TB. If you have any extra bits for synchronization purpose of commutator and decommutator, here nn plus a into TB, like that we have to take. Okay, this is about TS. Conveniently, you can able to apply this one when you have same frequencies for the two signals. But here what we have the problem in the sense, here one is 1K, second one is 1.5K. So which frequency we have to consider in order to have this sampling interval or the sampling frequency? Okay, that is the question. Why do we have here two different frequencies and how to approach this one means, for example, you are working at Nyquist frequency. So Nyquist frequency means 2 times of the maximum frequency of the signal. If you apply this 1K, what is the maximum frequency you will get? 2K. Okay, Nyquist frequency is equal to 2 times of FM. If you take this 1K only, you will get a 2K. But if you take this one, you will get a 3K. According to the question, according to the sampling theorem, Fs must be greater than 2FM. If you take this one, you will not satisfy this 1.5K. You observe here, if you take this 1K, how much you will get? 2K you will get. But what is required for 1.5K? 3K is required. So if you take this 1K, you will not satisfy this one. But if you take this one, what will happen? You see, the FM is 1.5K. So what is 2FM? 3K. 3K means you are satisfying Fs is greater than 2FM here also. Okay, here just 2K is enough. 3K is also okay. 4K is also okay. 5K is also okay. But what is the minimum we have to take? 3K is enough. If you take 3K, then this is satisfied. This is also satisfied. So what FM value we have to take? 1.5K. Okay, so FM is equal to 1.5K. If you take, both will be satisfied. So what is Fs now? 2 times of FM, that is equal to 3K. Okay, so what is TS? 1 by Fs. Like that we can able to take. So what is the minimum value of the permissible sampling rate? That means they are asking this Fs value only. So answer is 3K. That is the answer. Next question. A stable linear time invariant LTI system has a transfer function h of s is equal to something they have given. H of s is equal to 1 by s square plus s minus 3. By factorizing this one, what we will get? S plus 3 into s minus 2. Okay. Then for this one, what are the poles we will get here? This is the real axis, this is imaginary axis, this is S plane. So by making denominator is equal to 0, s is equal to minus 3, s is equal to plus 2. Like this we will get. Okay. Then to make this system is causal, it needs to be cascaded with another LTI system. Okay, having a transfer function h1 of s. This is another what we can tell LTI system. It is to be cascaded with this one for making this system is equal to causal. Okay, a correct choice of h1 of s among the following is. Okay, one by one we will check. If you take option 1, we need to cascade. Cascading is nothing but if it is in time domain, the resultant what we can tell resultant impulse response is a convolution between the two. But it is in S domain. So resultant impulse response in S domain is a product of the two impulse responses. So first impulse response is 1 by s plus 3 into s minus 2. Now if you take option 1, by multiplying these two, resultant impulse response is 1 by s minus 2. And if you take this one and draw the pole 0 plot, you will get here 2 plus 2. Pole is there on right side. It is not stable one. Okay, because if it is 2 here, in order to make it causal, what is the condition? Causal system means with respect to ROC, what we can tell? ROC is right of the rightmost pole. For example, if you assume it is causal, like this you have to take right of the rightmost pole, but it is not including j omega axis, so it will not be stable. So this option is wrong. Now we will check option 2. Option 2 is s minus 2. By multiplying this one with this, what is the resultant transfer function will get? 1 by s plus 3. How to draw the pole 0 plot? Here minus 3 is there. Okay, so this is the pole we have. According to causal system, what is the condition? The ROC is right of the rightmost pole. So from this we have to take totally right side. Now this ROC is including the j omega axis. Whenever j omega axis is included, it is stable, and we have taken right side, that means causal also. So stable and causal condition is satisfied. So answer is this one. Okay. So when you cascade this given system with the system having the impulse response is s minus 2, then the overall system will become causal and stable. Next question is related to sine wave can be converted into the square wave. That means analog question. Okay. Sine wave can be converted into the square wave using monostable, Schmidt-Trigger, clamping circuit and a stable multivibrator circuit. Monostable multivibrator output is only one pulse. Okay. Schmidt-Trigger is the right answer. Schmidt-Trigger can take the input and it will provide output is in the form of the square wave. Why? Schmidt-Trigger is actually comparator. Schmidt-Trigger actually comparator. It includes the positive feedback. That's why it is working as the comparator. Okay, comparator output can be high or low. That means the comparator outputs are either plus Vsat or minus Vsat. So depends upon the input signal. One time it will get plus Vsat, other time it will get minus Vsat, again plus Vsat, again minus Vsat. Surely the output changes in between only 2 levels. Okay. Only 2 levels means what is the shape of the output signal? Square wave only. That is the way. Okay. And if you want to talk about this option C, now the correct option for the given question is Schmidt-Trigger. Clamping output, clamping circuit. Okay, what it will do? Whatever the input you give, it will be clamped. That means some DC value will be added. Either the signal will be shifted to upside or downside. It will not produce square wave. If you give square wave, output is square wave only by adding some DC. But if you give sine wave, output is also sine wave only. For the clamping circuit I am telling. Okay. So it is not the correct option. A stable multivibrator can produce square wave. Can produce a square wave. But it will not take the input as the sine wave. Okay. You need to understand the difference between those two. We need the circuit which can convert sine to square. That is the Schmidt-Trigger. A stable multivibrator output is a square wave only, but it will not take input is the sine wave. Okay, so that the correct option is Schmidt-Trigger here. Next one. The rise time of the low pass RC circuit is given by. Answer you need to remember, that is 2.0 RC. How did you get that one? Means first to draw this low pass circuit. RC low pass circuit is this one, and you can work in S domain. So Vi of t, S domain where representation is Vi of S, V naught of t representation is V naught of S. This is C is there. So in S domain 1 by Cs, this is R. In S domain also that is R. You can take V naught of S is equal to, according to voltage division rule, Vi of S into 1 by Cs by R plus 1 by Cs, it is equal to, you can write Vi of S by 1 plus RCS. And you can take 1 by RC is common, Vi of S, this is S plus 1 by RC. Like this you can able to write. Okay. Take Vi of S is equal to 1 by S. Why? Vi of t is equal to unit step signal I am taking. Vi of t is equal to U of t. So Vi of S is equal to, you will get 1 by S. So substitute here, then you will get 1 by RC, 1 by RC, it is 1 by S into 1 by S plus 1 by RC. Okay. Now you can apply here partial fractions and you will get like this 1 by RC. Here RC you will get RC by S plus RC by S plus 1 by RC. You may get here minus, just to check it about that one. So RC you can take common and that will be cancelled. It is 1 by S minus 1 by S plus 1 by RC. Now apply inverse Laplace transform, then you will get V naught of t is equal to 1 minus e power minus t by RC into U of t. This is the expression for output when you apply the step input for the low pass signal. Now what we need actually, rise time we need. What is the meaning of rise time? The time taken by the output to rise from 10% to 90% of the final output. Okay. If you see this particular nature of the output, it is actually exponentially increasing signal. At t is equal to 0, e power 0, 1 minus 1 is 0. At t is equal to infinity, e power minus infinity is 0. So output is 1 you will get. Okay, 1 minus 0 is 1. So rise time is nothing but, what is the 10% of 1? 0.1. So this 0.1 you can achieve at t is equal to t1. On x-axis time is there. What is the 90% of 1? 0.9. This 0.9 you can achieve at t is equal to t2. This difference is tr. Rise time is equal to t2 minus t1. Okay. So using this mathematical expression we can get this one easily. So for example, you are working for t1. t1 means output must be equal to 0.1 is equal to 1 minus e power minus t1 by rc. Okay. Get t1 from this one. T1 is equal to something. And when you will get 0.9, that means t is equal to t2. So 1 minus e power minus t2 by rc. Get a t2 from this one. Take the difference between these two. So tr is equal to t2 minus t1. You will get a 2.2 rc. That's it. Okay. Next. So next question is related to RC integrator circuit. Output is taken across. Already just now we have seen the RC integrator only. Okay, low pass filter can be acting as integrator when RC is very, very large. Okay, every low pass filter cannot be acting as the integrator. The low pass filter can be acting as integrator when you take the time constant RC is very, very large. That is the point you need to remember. Now the question is very simple. Where you are taking the output means across the capacitor. Okay. Next question is related to ripple factor of the power supply is a measure of. Okay, ripple factor actually we are taking the ratio between, okay, how much amount of AC component is there with respect to DC component. Okay, so its filter efficiency, its voltage regulation, diode rating, purity of the DC value. Okay, this is the correct option. Okay, so we are comparing the RMS value with that means AC component value with the DC component value, means we are checking about the DC only. Okay, next one. So if the diffusion emitter diffusion capacitance and transconductance of a transistor at high frequencies are, so they have given diffusion capacitance that is 100 picofarad, and they have given transconductance. Generally transconductance is represented with GM, that is 50 milliamps per volt respectively. Then the frequency at which the short circuit common emitter current gain attains unity magnitude. Okay, so short circuit current gain achieves unity magnitude. This is what they have asked. Okay, so we have the formula for this one. Actually short circuit current gain is nothing but you need to take load resistance value is equal to 0 ohms. Okay, the output terminal should be grounded. At this particular moment we need to work out. Okay, and they have given clearly it is about high frequency. High frequency means pi model we have to use for the transistor analysis. Okay, and if you take the frequency versus gain plot, then you will get like this. What they are asking now, this particular gain should become 1. At what frequency it is becoming 1? That means unity. That one is represented with FT. Okay, so that is what we need to calculate. So it is basically given using the RC is equal time constant formula only. So if you write equation for example frequency means what here, RC is equal to tau, that means 1 by F, like this you take 1 by T. So 1 by T is equal to what we can take, FT is equal to 1 by RC, that means GM by C, diffusion capacitance 2 pi. Okay, this formula FT is equal to GM by 2 pi CD. Okay, here what I did in the sense, just in order to have the correct formula, what we need to do, we need to follow the units actually. Okay, we know RC is equal time constant. So if you send this FT this side, 1 by FT, that means seconds we will get now. 1 by frequency means seconds only. So seconds is equal to this side what we have, CD we can send, and GM is coming like this. So 1 by GM means resistance only. So RC is equal to time constant. Like that, the units you need to check without forgetting the formula. Now what we need, they asked about the frequency only. So frequency is equal to transconductance value is 50 milli they have given by 2 pi, and diffusion capacitance value they have given 100 pico. So you can able to substitute the formula. Okay, you can able to substitute the values properly and you can able to get the answer easily. Okay, simple calculation only you can able to perform this one. Okay, in megahertz you will get the answer for that one. Next, A JFET has got the following specifications. So VGS off, that means V pinch off you can take, or VGS off also you can take. So VGS off is equal to -2 and IDSS is equal to 4 milliamps. When applied, VGS is 1/4 of the VGS off. So VGS they have given is 1/4 of the VGS off, 1/4 of VGF off. Then the drain current of the device. So they asked about drain current ID. So this is the about the drain current means we have the formula ID is equal to IDSS into 1 minus VGS by VGS of square. That is what we can write. But directly we don't have VGS. They have given the condition, so we can calculate that one. So 1/4 times of -2, that means -1/2 will get. Okay. So substitute the values. IDSS is 4 milli. 1 minus VGS is -1/2. Okay. It is 1/4 of the VGS of so that I have taken like that. Next VGS of is again -2. So this is what we can take. So it is equal to 4 milli. It is 1 minus. Okay. So 1/4. So that is equal to 4 milli into, it is 0.25. So it is 0.75. So you can calculate that one. So it is equal to 4 5 is 20. 4 7 is 28. That means 30. It is 30. So like this we can take. So finally you will get here 3 milliamps. Okay. So in this way you can calculate. So this formula you should know regarding the JFET. Next question is related to again JFET only. So voltage divider bias circuit uses N-channel JFET. Okay. So N-channel JFET I have taken. This is the symbol for the N-channel JFET. Gate, drain, source. So they have given that voltage dividing bias. So R1, R2 we have to take na voltage dividing bias. R1, R2, and here drain resistance will be there and source resistance RS will also be there. Okay. So this is VDD. This is a voltage dividing circuit for JFET. Okay, N-channel JFET, as it's an active device with VDD is equal to 25. So it is 25 volts, and to have minimum VDS is equal to 10 volts. From here to here they are telling it is 10 volts. ID maximum is equal to 3 amps. So current ID is equal to 3 milliamps. The value of the drain resistance will be, okay, so this value we have to calculate, and they have given RS is equal to 2.25 kilo ohms. So simply if you know the circuit you can able to answer this one. What is required here? Everything is there, just we need to calculate RT. That means KVL we have to apply. What about current? ID current is flowing through this one. Here also ID current is flowing. Okay. So what is that KVL equation also I am writing? VDD is equal to IDRD plus VDS plus ISRD. So it is 25 is equal to ID is 3 milli they have given. So 3 milli into RD plus VDS is 10 plus RS is 2.25 K. This is multiplied with 3 milli. So just unknown value is RD. If you calculate you will get 2.75 kilo ohms you will get. Okay. Next question is related to in RC phase shift oscillator the circuit using BJT, which type of feedback is there in that? Generally in feedback amplifiers, first of all you need to identify what is the feedback element. Feedback element. If this feedback element is connected to output node directly, then voltage sampling is there. Voltage sampling, otherwise current sampling. I am telling the condition for if feedback element is directly connected to output node. Directly connected to the output node, then that is called voltage sampling. If it is not connected, current sampling. Next, if the feedback element is directly connected to input node, then that is shunt mixing. Otherwise, series mixing. That's it. Okay. Now the question is related to RC phase shift oscillator. How it will be there? RC phase shift oscillator. Here you can draw RC phase shift oscillator using JFET, using operational amplifier, or using BJT. Whatever it may be, the basic amplifier is this one. Exactly from the output we will take the feedback network. 3 RC networks will be there. Okay, this is a feedback network. This will be given to input. So this entire feedback network is connected to the output node directly, is connected to input node also directly. That means voltage sampling is there, shunt mixing is there. So what type of feedback is there? Voltage shunt feedback is there. So this is the correct answer. Okay. Next one. The output voltage of the circuit shown below is, the question is based on the operational amplifier. So if you see the question, here negative feedback is there. Output is connected to the inverting terminal of the operational amplifier. So it is a negative feedback. So it can be working as the amplifier. This non-inverting terminal is directly grounded. Okay. So we can able to apply virtual ground concept because here negative feedback is there. And then here 1 kilo ohm resistor is there. It is simply inverting amplifier. And we have the formula also. Okay. So what we need to calculate? Output voltage only. So output voltage is equal to minus RF by R into input voltage. This is applied for inverting amplifier. So directly we can able to take. So it is equal to minus RF is 10K by R is 1K and input resistance, input voltage value is 500 milli. So it is equal to just minus 50 millivolts. Okay. So KK will be cancelled. Sorry, it is 5000 milli. 5000 milli. That means minus 5 volts. Okay, like this we can write. Next one, the Boolean expression x dash y plus xy dash plus xy is equivalent to 2. Okay. So just we have to simplify this one. For example, you consider this is f. So that is equal to x dash y. In these two you can take x is common. So y dash plus y. Okay. If you take y is 0, y dash is 1. So 1 plus 0 is 1. Or if you take y is 1, y dash is 0. So that again 1. Either you are taking y is 0 or 1. You will get this summation is equal to 1. So simply x dash y plus x into 1 means x only you will get. And this can be written as x plus x dash into x plus y. Distribution formula, like that we can write. So this x will be added to x dash and x will be added to, that means R operation with y also. Again x plus x dash means according to this one we can take it is also 1. So answer will be x plus y. So this is the correct option. Okay. Next question is related to flip-flops. If the input to the T flip-flop is 100 hertz, the final output of the 3 flip-flops that are connected in cascade. That means here 3 stages are there. First flip-flop, second flip-flop, third flip-flop. The input to this one is having the frequency 100 hertz. Each T flip-flop will be having the output. That output frequency is 1 by 2 of input frequency. Okay, like that we have to take. So flip-flop output, first flip-flop output is divide by 2 anamata. Okay, divide by 2. Okay, input frequency by 2. Why we have to take like that? You take input signal is like this. Input signal is like this. Either you are using the negative edge triggering or positive edge triggering. What will happen means the change in the output will be happening for every negative edge triggering, for example. So here change is there, here change is there, here change is there, here change is there. So by observing this one we can tell the time period is becoming 2 times of the first signal time period. That means time period is increasing means frequency will be decreasing. So if it is f, it must be f by 2. So f by 2 is the input for this one. Again by 2 we have to take, that means f by 4. This f by 4 is the input for this one. That means f by 8 is the output of this one. That is what we need to perform. So here we are applying 100. So it will become 50. It will become 25. It will become 12.5. So this is the answer. Next question. Which of the following consume minimum power? Okay, minimum power means always we have to remember these things. Okay, which is the fastest logic family, which is consuming minimum amount of power. All those things we have to remember. So minimum power means we need to know about CMOS. Okay. The output Y of a 2-bit comparator is logic 1 whenever 2-bit input A is greater than the 2-bit input B. So here they are giving that A and B are 2-bit numbers. Okay, A is 2-bit number, B is also 2-bit number. For example, 2-bit number means how many combinations you have? 0, 0, 0, 1, 1, 0, 1, 1. B is also 2-bit number. So it is also having 4 chances, na? 0, 0, 0, 1, 1, 0, 1, 1. We have 4 possibilities are there. And they are telling that output is logic 1 when A is greater than B. Whenever A is greater than B, output is equal to logic 1. That is what they have taken. Okay. So the number of combinations for which the output is logic 1, that is what we have to calculate. Okay. It is not true for only single combination. Okay. For the other combinations also, it is logic 1 only. Like that, how many combinations are there? That is what we have to take. So A is greater than B. That is what we need to check. For example, A is 0, 0. No chance to get A is greater than B, na? Because that is the minimum value. For example, if you take A is equal to 0, 1, then B if you take 0, 0, then you will be having A is greater than B. So that is okay. Now, next you take A is equal to 1, 0. If you take A is 1, 0, you may take B is 0, 0 or B is 0, 1, but you cannot take these two. So here B is having 2 chances, 0, 0, 0, 1. This is okay, this is also okay. Now if you take A is 1, 0, 1 is over, 1, 0 is over. Okay, next 1, 1, correct. Okay, A is 1, 1. Now you are here. That means you can take B 0, 0, 0, 1, 1, 0 also you can take, but you cannot take 1, 1. Okay, both will be equal. So here you have 3 chances, 0, 0, 0, 1, 1, 0. That means totally how many chances you have? 6. That is the answer. Okay. Next, in a collector coupled monostable multivibrator circuit using BJTs, the period of quasi-stable state of the circuit in terms of RC values. So it is the standard one only. In using BJT, if you take the monostable multivibrator, how much time you will get means 0.69 RC. This many seconds, the output will be there in quasi-stable state and then automatically coming to stable state. So in monostable multivibrator, only one stable state is there and one quasi-stable state will be there. Okay. So I am taking this lower level is the stable state. In order to change the stable state, you need to apply triggering input. So here trigger input is required. When you apply the trigger input, the state will be changed to quasi-stable state. How much duration it will be there in the quasi-stable state means T is equal to 0.69 RC. After completing this much time, automatically it will come to stable state. Here, triggering is not required. Triggering is required whenever you want to change the stable state only. Okay, that is what you need to remember. And in monostable multivibrator, you are having one AC coupling, one DC coupling. Okay, so when you trigger is required in order to change the state of the stable state, okay, then it will be available for 0.69 RC seconds. How to analyze this one means, first you take the stable state, okay, then one transistor will be in the on state, other transistor will be in the off state. You need to apply the triggering input. Then the states will be changed. Okay, then the capacitor, whatever for AC coupling purpose, whatever the capacitor you have kept, that capacitor will be starts charging. Okay, whenever that capacitor is charging up to certain level, then again states will be changed. How much time is taken by the capacitor to reach up to that certain level? That is 0.69 RC. Like that in the derivation process you can able to understand. Okay, so in this way you can able to remember 0.69 RC. Next question is related to, okay, D to A converter. In this particular case, in a D to A converter made with the binary weighted resistors. Okay, this is made with the binary weighted resistors. It is difficult to maintain high accuracy as the number of bits increases. Okay, that is true. Because what is the reason for that one means, here you can able to check, that is actually obtaining the stable and precise resistors with a large spread in their values is very difficult. Here weighted, okay, weighted resistors, when you work with this one, lot of resistors are required with accuracy, but it is difficult to get that type of resistors. Okay, so because of that one we can tell it is difficult. Next, two systems with impulse response H1 of t and H2 of t are connected in cascade. Okay, we have taken two systems with impulse response H1 of t and H2 of t. Like this we have taken. Whenever two systems are in cascade, the cascaded connection we can able to take like a single system only. But it is having the impulse response, that is convolution between these two. One thing you need to remember, it is not multiplication, it is convolution. When you work in time domain, this convolution you have to take. But when you work in frequency domain or S domain or Z domain, you can take product only. Okay, but only in time domain you have to take the convolution. That is what you need to remember. Question is about for that one only. So overall impulse response of the cascaded system is given by convolution of H1 of t and H2 of t. Next one, the Fourier transform. Okay, the Fourier transform of rectangular pulse of width tau seconds and having the unit magnitude is. So we have to take one rectangle pulse of width tau, that means 0, it is tau by 2, it is minus tau by 2, and amplitude is 1. For this one, the Fourier transform. The standard representation generally, if it is amplitude A, is given by A tau sampling of omega tau by 2. Like this we can do. Okay, sampling is different from sync. Okay, I will tell in detail. But here they have given A is equal to 1 only. So you can take that one. 1 into tau is tau. Tau sampling of omega tau by 2. This is the answer. But if you see the options, they did not use sampling function, they used a sync function. So we need to have what is sampling, what is sync. So sampling of x means you can write sin x by x. What is sync of x? That means sin of pi x by pi x. Like this we can write. Okay. Now what is the relation between these two? What is the relation between these two means, if you write sampling of x by pi, okay, what you will get? Sin, okay, sin x by pi by x by pi. Now you write sync x by pi. It is sin, when you write about sync, we have to multiply with pi na? So sin x by x, that is equal to sampling of x. So this is the relation. Okay, so here I am writing sync x by pi is equal to sampling of x. Now what we have? Sampling of omega tau by 2 we have. Omega tau by 2. It is equal to, we have to write this one in terms of sync. That means sync by pi we have to take na. So omega tau by 2 pi. Like this we can write. But here amplitude tau is there. So you take tau. Here also you take tau. But even if you see the options, they have used, okay, in terms of f they have given, in terms of omega also they have given. So we will see in terms of f now. Okay. So it is 2 pi f tau by 2 pi. So 2 pi will be cancelled. Tau sync of, we can write f tau. Okay. Tau sync of f tau. Your answer is not matching, but you can able to take this one. Okay. You need to have sync representation and sampling representation, and you need to know the relation between those also. Okay. So I will tell once again. So this is A tau sampling of omega tau by 2, and since A is equal to 1, we have taken tau sampling of omega tau by 2. Then this one is to be written in the sync function. So how to write that one? Sync function is nothing but sampling of x is nothing but sync of x by pi. Okay, just we have to take sync, whatever the x quantity is there, by pi we have taken. Okay, and omega can be written as 2 pi f. So that 2 pi, this 2 pi will be cancelled, simply f tau you will get. Okay, like that we need to perform. Next one, the Z transform of the sequence x of n is equal to u of n minus u of n minus 2. So Z transform means, for example, x of n is there, its Z transform is given by capital X of z. Okay, and if you have, for example, a power n u of n, the standard signal, what is the Z transform means? Z by z minus a, and mod z is greater than mod a. You take A is equal to 1, then you will get U of n. That means z by z minus 1 mod z is greater than 1. Like that we can get. Okay. Now using this particular shifting property. Okay. So x of n minus n naught is having the z transform z of x of z into z power minus n naught. Okay. Now you apply what we require here. U of n is over, but here u of n minus 2 is also there. So u of n minus 2, when you have shifting, what will be there? Z by z minus 1 z power minus 2. Like this we can able to write. Okay. So now here subtraction is there. So according to linearity property, we can take subtraction of the z transforms also. So one is z by z minus 1 minus z by z minus 1 into z minus 2, z power minus 2. So take z by z minus 1 as common. So 1 minus z power minus 2 will get. It is z by z minus 1, 1 minus z power minus 1, 1 plus z power minus 1. Like this we can write. Okay. Now we can simplify this one further. If you take here z is common, 1 minus z power minus 1. Like this will get. It is 1 minus z power minus 1, 1 plus z power minus 1. So this one will be cancelled. Z will be cancelled. So answer will be 1 plus z power minus 1. 1 plus z power minus 1. So this is the correct answer. Next one is related to communication, that is amplitude modulation. So in amplitude modulation, dash percentage of total transmitted power is used for carrying the message signal under best conditions. Okay. So it is related to percentage of power. So we can take PT is equal to PC into 1 plus mu square by 2. This formula is valid for amplitude modulation. And percentage of efficiency, if you observe, that means sideband power by total power into 100%. Okay. Because information is available in the sidebands only. That's why we are taking that one in the numerator and comparing that one with the total power. Okay. So here sideband power is nothing but PC into mu square by 2. Total power means PC into 1 plus mu square by 2. So if you perform that one, you will get mu square by 2 plus mu square into 100%. So under best conditions means mu is equal to 1 you have to take. Then percentage of efficiency is equal to 1 by 3. That means 33% you will get. So 33% can be transmitted in the sidebands. That is there in the sidebands. Okay. And remaining 66% is wasted in terms of the carrier power. Okay. So what is transmitted means here 33% only. Okay. Next one is related to Hilbert transform. So if you see all the modulation techniques in the this particular analog communication, this SSB equation is involving the Hilbert transform. Okay. Here S of t is equal to, you are required to have equation in terms of m of t and m cap of t also. This is the Hilbert transform of m of t. It will provide 90 degrees phase shift. Okay. So answer is simply SSB. Next, the frequency range used for the FM broadcasting. It is very general question. Okay. For AM, for FM, you need to have the frequency ranges. Okay. Daily we are listening about the FM that is having any FM channel. If you observe, its frequency range is in between 88 megahertz to 108 megahertz. Okay. So with this we have completed the questions related to electronics in TS GENCO 2015 question. Okay. All the best. Thank you.